Hello again. So in this lesson we're going to look at plotting a quadratic graph. We're going to look at solving quadratics graphically, and we're going to look at finding the roots and the turning points. So starting with the easy part first, this is plotting a quadratic graph. So we've got this question here, and that is to draw y equals 2x squared minus 6. Well, to draw any graph you need coordinates of x and y. So if you're given a graph, you can see the extent of the coordinates used for x. In this case, we have got -2, -1, 0, 1 and 2. So I won't need the -3 or the 3. Sometimes you get given a table, sometimes you get given a graph, sometimes you get given neither of these. And if that's the case, I would suggest to you to use values of x of -3 all the way to 3. Right, so we've got x equals, in this case, -2, -1, 0, 1 and 2. We have got to find values of y, and we do that by substituting this value of x into here and substituting this value of x into here and so on. So let's start with x equals -2. So -2 squared is 4, 2 4s are 8, 8 minus 6 is 2. So on this next one we've now got x is -1. So we've got -1 squared is 1, times 2 is 2, 2 minus 6 is -4. X is 0, 0 squared 0, times 2 is 0, minus 6 is -6. X is 1, so that becomes 2 minus 6, which is -4. X is 2, that's 8 minus 6, which is 2. And there we have our coordinates. -2, 2, so -2 across and 2 up. We have -1, -4, -1 and down to -4. And then we've got 0, -6. We've got 1, -4, 1 across, -4 down. And then we've got 2, 2. Now, when you're drawing a quadratic, it's a smooth, curved line. And a quadratic will either look like a U or an N, and they are curved. They don't have any points like this. You don't draw straight lines between the coordinates. It is a smooth line every time. Okay, so I'll draw my smooth line on here. Okay, that's not too bad, a little bit wobbly over here, but generally it's fine. So again, key points is you're not drawing straight lines between the coordinates. That's really important, and it needs to be as smooth and natural as possible. So all I'll do to finish that off is label this y is equal to 2x squared minus 6. Okay, we're on question 2. We're going to use our graph to find the value of y when x is equal to 1.5. So here we go. Let's find the values of x. So here we go, there's the values of x. X is 1.5 is here. All we do now is draw a straight line down until we actually hit that graph. Once we've got that graph, we draw a straight line across, and our value of y, in this case, will be -1.5. Now we can check that very easily by putting x equals 1.5 back into this equation. And if I do that, I do get y equals -1.5. I've just noticed I missed the minus out there, so just be careful on that. So there's my check. So that's plotting a quadratic graph and using it to find values of y when you're told values of x. Okay, another question here. In this question, we're asked to solve this equation graphically, and that means drawing it. We'll come back to the solutions in a second. So the first thing we do is we plot the graph y equals x squared minus 3x minus 1. That is exactly the same idea as we've just done a minute ago. If you've been given the graph, you've got the extent of the values of x as we have here. So in our case, we've been told values of x go from -3 to 3, so we can use them. But again, if you haven't been told that, you will need to decide upon those values. So now we need to find values of y by substituting these values of x into this equation here. Okay, so I've just done that. So now I need to plot this graph. -3, 17. I haven't got 17 on there, so I'm going to ignore that one completely. -2, 9. Well, I think I can probably manage that. -1, 3. 0, -1. 1, -3. 2, -3. Finally, 3, -1. Okay, we just draw that smooth curve back in. Okay, so there's the graph drawn. I'll just label that. Y is equal to x squared minus 3x minus 1. Notice at the point here, I actually brought it in to be a smooth natural curve. It didn't point here and it didn't go flat here either. Okay, so we've plotted the graph. We now need to use the graph to solve this equation here. The first thing to do is recognize that this equation y equals x squared minus 3x minus 1 has the same components as the question number 1, x squared minus 3x minus 1 equals 0. Now, if you think about that, that means y equals 0. So for question number 1, we're actually going to solve this when y is equal to 0. What that means is we draw a straight line across all the points where y equals 0. That is on the x-axis. So that line there is y equals 0. And to solve that, we find the coordinates of x where the quadratic and the straight line cross. So we're looking for the coordinates of x here and the coordinates of x here. So in this case, we can say that x equals, it looks like about a third, so minus 0.3 recurring, and x equals 3 1/3. So I'm going to put 3.3 recurring. So that is the solution to the equation x squared minus 3x minus 1 equals 0. Let me move this up to give us some space. So now we're on question 2. Okay, so now I'm going to use y equals x squared minus 3x minus 1, and I'm going to look at this equation here that I've been given. X squared minus 2x minus 2 equals 0. And my aim here is to try and find the difference between these two. And the difference in this case should give me a straight line that I can draw onto this graph. So for example, I could draw a straight line through here, if that's where it was. And then I can use that straight line to find where the values of x would be, and those would be our solutions. Okay, so if we look at the difference here, x squared minus x squared is 0, minus 3x minus 2x, so that becomes minus 3x plus 2x is minus 1x, and minus 1 minus 2, so that becomes minus 1 add 2, becomes plus 1, and that is our new value for y. So I've got to plot this, so I'm now going to plot y is equal to minus x plus 1. Going back to our straight line graphs, the y-intercept is 1, so that's 0, 1, so 0 across 1 up. And our gradient m is 1 across 1 down because it's negative 1, so 1 across 1 down. If I go from here, I go 1 across 1 down, 1 unit across, 1 unit down, 1 unit across, 1 unit down, 1 across, 1 down, 1 across, 1 down. I draw that in. I'm now going to solve this equation graphically. And what that means is I'm going to find the values of x. Now the values of x occur where those lines cross. So all you do here is you look at where they cross and you drop a straight line down, and that will give you the value of x for one of the solutions. Do the same over here, and that's the value of x for the other solution. So in this one we can say x equals around about minus 0.7, so x equals minus 0.7, and x equals around about 2.8. Now, because you're using a graph, these are classed as estimates. And that's it. That's how to solve equations graphically. Let's move on to finding the roots and the turning points. So in this question here, we're looking to find the roots. Now, before we find the roots, let's establish what a root is and what a turning point is. So I'll go back to that other question. So a turning point is either at its peak or its trough. So this position here will be our turning point. Our roots are where the graph cuts the x-axis. Not all quadratics have roots. So for example, if you had a quadratic that is here, well, clearly it does not cut the x-axis, therefore it has no real roots. Okay, so finding the roots and the turning points. It says, first of all, we've got y is equal to x squared minus 2x minus 1. As an aside, we can also reference that as the function of x, or the f of x, is equal to x squared minus 2x minus 1. So the first question is to use the graph to find the turning point. So obviously to do that, I have to plot this first. Okay, there's my graph. I'll just label that. And now I need to use the graph to find the turning point. Well, that's fairly straightforward. The turning point is where the graph is at its lowest or its highest. So the turning point for question number 1 is just 1 minus 2. Now looking at question 2, we're going to find the turning points algebraically. Now, the reason for doing this is just a bit of a check, really. To do this, we need to show y equals x squared minus 2x minus 1 in the completed square format. So to do that, if you remember, y is now equal to, we have the bracket, we have the x, we know it's going to be squared. So we take, if you remember, that is ax squared plus bx plus c. So we take the value of b and we half it. So we are going to minus 2 over 2 is just 1. Take half of b squared away from that. So we have 1 squared is 1 and we take it away. And then finally we put c on the end. So therefore we now have x minus 1 squared minus 2. And the reason for that is if we know y is equal to x minus p squared plus q, the turning points are at pq. Just be careful here because in this case we've got a negative p. Notice that's a positive p. So if we look at this, we have now got our turning points at, well, p is minus 1, so we've got 1. And q is minus 2, that remains as it is, and that is exactly as we had it. So I can check my turning points algebraically as well. And the final question is to find the roots or determine the roots of this function. So the roots are where the line crosses the x-axis. This one here looks around about minus 0.4. So we've got x is equal to minus 0.4 and we've got x is equal to, and again that looks around about 2.4. These are estimates, they are not accurate because they're taken from a drawn line. So it'll be in that region of those two values. And that's how we find the roots and turning point of a quadratic. I hope this video has been useful, and if it has, please like and subscribe, and then move on to the next video on curved graphs, where we'll be looking at cubics and reciprocals.